Recording has started. Welcome, everybody, to our webinar about metadata. We will be providing a short introduction about the FedOSC project, which is the context of this webinar, and then we will get right to the program. The FedOSC project is a BELSPO funded project that's operated by Belnet together with the Federal Scientific Institutes, with the purpose of promoting open science and fair data practices in the federal research community. We are developing tools, services, working on policies, and delivering trainings such as this one. We will be diving into a high-level introduction of the concept of metadata for research data for the next half hour or so, and then we'll move on to the rest of the program with presentations on practical use cases of metadata standards. We will then regroup for a Q&A across the board, across all the presentations. I would like to give the floor to my wonderful colleague, Anne-Rose, who is a FedOSC data steward, specialist in the arts cluster. Anne-Rose, the floor is now yours.
A lot, Judith. So let's first talk about the metadata basics. Metadata in general. I want to start with a quick Menti, please. There's a code on the next slide, which you can either scan with your phone or Anna also put the Menti link in the chat box, so you can also open it there. And answer the question of who of you has already searched in an archive or a database, catalog, repository, search engine, or even a SharePoint this week?
I will give it a few seconds and then show the responses if that's okay, just to keep a little bit of suspense. Maybe 10 more seconds. Let's take a look. Oh, wow, I'm surprised.
Yes. So what you did in searching something in one of those systems was putting in some information about the thing you were looking for in the system. And that is actually already some part of metadata. As you could already guess, metadata is not about abstract concepts, but instead it is contextual information that makes things findable and understandable. Here we have a few everyday examples, for example, a spreadsheet column header or an archive catalog, then also a dataset description in a repository or file properties like author and creation date. Yeah, and metadata is information that describes other data, helping people understand what it is, where it comes from, and how it can be used. When structuring data, when structured, you can use agreed standards, and it can be easily shared and processed by both humans and computer systems. On this slide here, we have provided a few definitions of some of the most important concepts connected to metadata, so you can have them available if you need them. I will not read out everything right now. So in general, metadata can have different functions. Not every kind of metadata has the same function. There is administrative metadata that enables the identification, management, and reuse of data. Then there is descriptive data that enables discovery, identification, and the selection of resources, and structural metadata that helps define the internal structure and relationships of a resource. And let's have a closer look at those. The first example is administrative metadata. On this slide here, we see an example of administrative metadata from Zenodo. We have the human readable Zenodo entry in the middle. and the connected exported JSON file that is also there for machines to interpret. Administrative data is it describes how the object is managed and under which terms it can, for example, be reused. Then the next one is descriptive and authority metadata. Descriptive data in general describes how an object describes the object itself. Authority data is a special case within that data. It is standardized descriptive information used uniquely to uniquely identify and consistently name entities, such as, for example, people, places, or organizations. Here, for example, in this entry from the Dataverse from University of Liège, you can see both descriptive information like the title in yellow, and also, for example, the ORCID of the connected authors in green. And then the last part is the structural metadata. And structural data tells us how parts of a resource are organized and relate to each other. It defines the shape, order, and hierarchy of information. And here we chose two examples, one from astronomy, from the Hubble Space Telescope that shows structural metadata, where the relationships between multiple images of the same object, such as their positions and distances are, and describes how data is organized within one single observation. And the other one, the small one on top, is a TAI-ML example that illustrates how the different chapters of a book are connected to each other on a very basic, like high-level level. Yeah, and so to sum up a little, what does metadata do? Metadata helps document a data set's provenience, content, authorship, and context, preserving its meaning and history. For example, like the astronomy, in astronomy, where FITS files records telescope and observation details, or for example, like in heritage collections, where the object metadata captures provenance and dating. It also allows machines, such as search engines and platforms like Europeana or data repositories, to find and display data, since they rely on metadata rather than file names or documents. And finally, metadata enables citation and linking of datasets and other resources, for example, through DOIs that connect data to publications or help build structured collections. And with that information, we go on with my colleague Francis, who tells us a little bit about metadata standards.
Yes, thank you, Anne-Rose. Yes, I will indeed talk a little bit about the standards, because if you talk about metadata, it's good to know that there are specific standards, and a first slide is also about, so what are they good for? First, a bit of a definition. So a metadata standard is a formally defined and community agreed set of elements, definitions, and rules that specify how metadata should be structured and encoded in a consistent way. So they ensure that a shared vocabulary, machine readability, and interoperability is possible across systems. So you could see it a little bit with the drawing. So there's the data, which has all the data points. The metadata is then really the description of how to get to the data and also to know about everything around the data. So metadata standards, they can be generic or discipline specific, and the value is in different levels of specificity. So when you look at the discipline, when you look at generic, so that's the first slide, specific standards, there are the ones as maybe some of you already know. That's like Dublin Core or data site metadata schema, or a DCAT, that's a data catalog vocabulary. So Dublin Core has as elements a title, a creator, a subject, date, an identifier. So they are good for broad research discovery, general repositories when they are cross-domain interoperable. Data site metadata is more on specific publications. So for citations, linking to publications and all-purpose repositories, and there they are made of DOIs, creator, the author, the title, publisher, etc. And then in the DCAT, that's the data catalog vocabulary. These are really specific for data catalogs and portals. So like the data.gov portal or the europa.data.eu portals. And they have an aggregation and harvesting of open data. So that actually is allowing that machine readability and interoperability. And at the bottom, there's just an example of a Dublin core. Voilà. Yes, next slide. So, and these are then the discipline-specific ones, and they are very, very, very specific. So there's for GLAM, there are a couple here mentioned like Lido, Mark 21, and CRM. And for instance, with the STEM track, there are others that are very specific that some of you might know. So like NetCDF, FITS, and DCOM. Then on the right of this slide, there are some representations of how you could visually show them and how they are all connected together. So the three examples here are different, let's say, metadata standards visualized. So now it's time for another Menti. So how many standards should I pick? I think Judith will have activated this question, so go ahead.
You should now see the new questions, the new question on Menti. So to the best of your knowledge, can you please answer the question that Francis is asking? How many metadata standards in general should you pick for a research project, for example? Okay. In case you're a little bit lost, we are pasting the link to the Menti in the chat box as well. Thank you, Anna, for that. Very practical. Okay, maybe 5 or 10 more seconds. I can see more people still clicking. Right, I will show the responses now. Are you ready, Francis?
Yes.
All right, not too bad, not too bad. Okay, so the majority of you are leaning towards a mix of discipline-specific and generic standards when you need them. What do we think of that?
I think that's a good way to look at it.
Yeah, of course, yeah. So this crew has already understood what the purpose of metadata standards is. So let's go back to the slideshow and continue with the presentation, please. And we're moving on to metadata scaling.
Yes, so now we talked about what is metadata, the metadata standards. Another element or topic to shortly touch upon is the metadata scaling. So following on the question that we just had in the Menti, so how much metadata should I add? So there may be a couple of things that are to be said about that. So when you're documenting for storage and preservation, there it's the more the better. So you can always imagine somebody else trying to look at the data that once was stored and so on. So the more information you can have, the better you can understand what the data was about. And in a specific but flexible standard is ideal. So yeah, if it's too tight, then you maybe can't do a lot with it. So if it's flexible, it allows you to do a bit more, which is obvious. And then if you look at it from a sharing point of view, so the minimum needed to find, cite, and to know what it is about is a title, a creator, a date, a description, and also a persistent identifier. So if possible, the more metadata is the way to go. And the better the metadata, the higher the fairness of the data. And definitely with the elements indicated here, what is then exactly the fairness? We will talk about that in the next slides. So where does FAIR stand for? So FAIR stands for it's a four-letter word, stands for findable, accessible, interoperable, and reusable. And the reusable, interoperable, accessible, and findable elements are actually both for humans and machines. So FAIR data could be fully open, but it can also be restricted, and it can be that you need to close it as you need, and it's actually following this principle. So it's actually as open as possible, as closed as necessary. FAIR is also a spectrum, so it means that you can have different degrees of FAIR, and the data principles, they are actually the guidelines for research data management within the European Commission, that already since 2018. And they are really at the center of, for example, the Horizon 2020, the Horizon Europe guidelines, but also the European Code of Conduct for Research Integrity. So let's go to what I wrote here myself. So when we talk about FAIR data, a big part of it is making it working in practice. So that comes down to metadata. So first, for data to be findable, it needs to have rich descriptions, persistent identifiers, and it should be indexed in searchable systems so that it can eventually be discovered. Next, accessible means that even the data itself, if it's even restricted, the metadata should remain available. So that way, people at least know the data exists and understand that it could be accessed, and understand how it could be accessed, of course. So for interoperability, rely on formal standards and shared vocabularies. This ensures that the data can be understood and combined across different systems and disciplines. And finally, for data to be reusable, it needs a clear license, detailed provenance information, and a description that makes sense within its specific domain. So overall, good metadata is not just helpful, it's one of the most important steps in making data truly fair. Then another question for you, Judith.
Yes, we would like to move back to the Menti. The question is already on, so dear participants, can you please go back to the Menti and let us know that you have heard what metadata actually is, what it looks like, and what it is used for. Maybe you were actually already using metadata or creating metadata without even realizing it. So please let us know. And while you are pondering on that question, I would like to bring this presentation to an end with a few take-home messages. Overall, given the definitions and the examples of metadata that were provided today, what is the things, the very few key elements that we can continue working on? Well, metadata is there to improve the visibility of your work by making it discoverable, especially if it is sharing or citation metadata. It ensures that it is made discoverable by people when they type on the right search engine, and also by machines between themselves. It makes data understandable and reusable across systems and users. You can also think about it as a little bit of documentation for your future self, for the reuse of your data set, maybe in a few weeks or in a few years. We definitely recommend to use and create metadata right from the start of the project. So not only when worrying about data dissemination, when sharing, so not only the authorship and the citation metadata, but also the other types of metadata that you have seen, descriptive and structural metadata. A mix of standards and a mix of good choices in terms of format, standards, and documentation, shape, and processes is also highly encouraged. So you can choose a metadata standard for each specific step and for each specific use that you have as early on as possible would be the best. Keep it documented and makes your life easier to use controlled vocabulary for the purpose of documentation. In short, metadata is definitely part of the research output itself. We've been working with metadata for publications without even knowing it. Well, the same is true for data sets. It ensures collaborations, mutual understanding, common languages, and is really the key accessory to data fairness. All right. That was the end of the introductory presentation. Thank you very much for your attention and for basically your presence. Even just connecting and listening already means a lot to us. If you go back to the Menti, we can see that a majority of us actually already used metadata and already knew about it. So that makes me very happy. I'm talking to a crew of experts, basically. I am now going to open the floor to questions. If you have any question, you can type them in the chat, or you can also just turn on your microphone or maybe even your camera and start talking. We will start the next part of this training session in 6 minutes.